Okay, can everybody see me? Can you hear me too? Hello? Is everything working on your end?
I can hear you and see you.
You can see me?
Yes.
Okay, very good. All right, well, we'll start now. First, I have some announcements. For those of you in group 1, we'll start at 7 o'clock unless you're an athlete that thinks they'll just come the same time you planned to do it before. Regarding the previous things when you came, that was a good breakdown. And basically you'll have 55 minutes again today to do it. And unfortunately, I know some of you wanted to delay it till tomorrow, but that interferes with the softball, as well as the fact that the other sections have already done it, the test last week. So basically I don't have anything regarding that. Now, I know some of you are anxious about the election and all that other nonsense. I ran for US Senate twice in Hawaii and Congress in New Hampshire once, and most of it's a game. Don't take it seriously. Have a cynical attitude about it because it really doesn't affect you. It probably never will. And I just want you to have a life and everything else because I didn't win, but I had a great time meeting people and I went on with my life as a chemistry teacher. So, and me and my family had a good time doing it too. So it's a kind of thing where in a way, it's like people trying to make an effort to change something, and then they just decide what the public wants. But again, whatever side you're on, it doesn't matter because our Constitution's set up in such a way, I encourage you to read it, to basically, that the only thing, major things gets done is by consensus anyway. So whoever wins the presidency, they'll have to work it out with Congress, both House and Senate. So that's life. So I've been through so many elections since the first one I remember in 1968, and life goes on, even though people freak out and everything else. Back in 1968, there were people blowing up bombs and hijacking aircraft and all sorts of other stuff. And that scared a lot of people too. So, but in any case, I hope that addresses any anxiety you have so you don't have any, or have a minimum amount for the test today. Yes. Well, that's just because the other faculty member has things. I already discussed it with Dr. Gerhardt, and I will give you a test back to look at, but basically I keep it. If you want to see your test, you can come in and basically I keep it. It was recommended to me not to give them back to keep, but the plan was, for the lecture test, the plan was, after everybody had finished taking the test, I got a couple students in quarantine that still may have to take it. And so basically my plan was, if I don't hear from that last person, I will pass them back to you tomorrow. But I purposely didn't do it before then because I didn't want people to be anxious about that previous test because there's nothing on the previous test that's on this exam. Okay, so it's not due to not effort, but I will think that the lab exam I don't give back, but this one I will, so you can use it to study. Yes. Well, just continue to work problems and go backwards through the chapters backwards to make sure you can fix the stuff you made things, and use the previous tests and quizzes that I've already passed back to you as a guide to help you. Because if you remember the last test, the worked out pages, a lot of that was on the quiz. And a lot of people didn't get the message that I wanted people to learn how to do it on the quiz first, and then they saw it again on the test. So just go back through the thing and go back through the homework problems you've been working through each chapter. That's the best thing to do because there really is no way to study for the test, so to speak, to just the test, because it's going to be a department exam that I have no way, I'm not making it up. The other department members who are tenured or, yes.
Our lab grade isn't a part of this grade, right?
They're two separate, and the lab grade was basically based on all the labs you've turned in so far, and the first test wasn't part of it because it's only 20% of the grade anyway, and most of the people got hundreds on it. So if they got an S or higher, it could be an A, whatever. It's it's still a thing because yes.
In lab yesterday, you said that the curve hasn't been added to the test yet. Is that the same in here? What are you going to add curves at the end for
Well, basically I curve them by the test. So the end, after everything's totaled in, I'll curve the final exam. I have a appropriate curve for the final exam. After that's been all done, then I do have a little bit of latitude regarding the quiz grades. Because if someone did really, really lousy on the quizzes and then did well on the tests, I tend to kind of ignore them. Because the whole point, what's the whole point of the quizzes? To prepare for the test, okay?
So if we like count the quizzes, our test rate staying the same. I'm trying to confused about how the tests are counted.
Well, everything is totaled up with numbers. It has nothing to do with personalities, everything else, it's all numbers because I curve each of the tests individually based on how all the class did and the timing regarding how many people were able to finish and everything else. All that stuff goes into it. And I've been doing this for a long time, so I know it's fair and totally objective. It's no favoritism at all because I don't even see the grade until I put it in the grade book. Yes.
I was just wondering, like the homework assignments and the extra points for the labs we got, like what are those points for the grade?
Sorry, the homework.
Like the
Oh,
homework
well, those are all quiz grades. Like the last take-home quiz I gave you, I'm giving everybody. I'm going to put it in the grade book. I'll go through turned it in complete, and basically I'm going to give everybody 30 points towards the quiz grade. So, so you have it. You could study from and look up the answers and spend your time with it. So.
But like the past homework assignments and like the lab.
Well, the homework assignments, they're just 20 points finished or whatever else. But the quizzes I've graded and turned back to you, those are in there. But again, if people did poorly on the graded ones and did better on the test, that's the whole point. I want people to do well on the test and know what's coming.
So they are going in for grade.
No, I look at all at the end. Say, for example, someone has a difference between a B plus and an A minus, and the B plus drags them down. The quiz grade drags them down. I have justification based on all the other grades that I can go by the A minus if they did well in the final. Do you know what I'm saying?
Yeah, but I'm not talking about the quizzes. I'm talking about like the homework assignments that you said you just.
Well, those are just called the quiz grade. I just put it all together.
Okay.
And the lab quizzes are part of the lab grade. It's just part of the thing. If people don't complete them by the end of the semester, they get 10 points taken off, a whole grade level taken off their grade. Yes.
So they're already in our grade, or you're adding them?
No, they're quizzes. They will be added at the end together with the total possible points and everything else. And it's just it's the 10% that makes up the quiz percentage. That's each individual assignment's maybe worth 1% or 2% or something. It's nothing. The point is to get you ready for the test. Yes.
So you were saying before that this test will most likely replace another, like one of our prior tests?
No, I'm not allowed to do that. I've done at other colleges where it was okay to do it is basically if I had 3 tests, if someone did poorly on the first or second exam, I would drop it and average the other 2 together. But I can't do that here. I've got to stay consistent with the rest of the department. So basically the policy is that basically I'll look at everything at the end. And as I said before, I have some latitude regarding if somebody has 1 poor test and 3 they did really well on, and the final exam they did well on, I'm more inclined to give them more credit for the stuff they did well on, not dwell on the stuff they didn't. Because again, it's what you need to know at the end of the semester, not how you struggled in the 2nd week or the 4th week or whatever, particularly on stoichiometry, when people don't really get it until a few weeks later after you've already tested. Yes.
Okay, so you said you're not going to drop them for the test?
I'm not allowed to.
I thought you said last week you were.
No, I'm going to take all that into consideration, and I've been given permission to minimize an outlier like that and rely more on the other for the final grade. You know what I'm saying? It's not going to drag someone down if they give enough justification that they earned a higher grade. And it's all about earning the grade. It's not about personalities or whatever. I don't play favorites. I don't play any favorites based on backgrounds or whatever else. And people are even concerned about in Iraq if I did that, if they were Sunni or Shiite, or if in Kazakhstan, if they were Russian or Kazakh. It's like, and I just said them the same thing I'm telling you. You don't worry about that. It's all based on the numbers and justifying earning your grade, okay? Yes.
Dr. Douglas.
Yes, Anna.
So you were saying that the quizzes are meant to prepare us for the test and that we should study the quizzes. Is there any way we can
Yeah.
get last Thursday's quiz back? Have you given it back to people that are in class? Can we come by your office?
Well, that wasn't a written quiz. It's one you emailed to me, right?
Yes, but could we get the grade, what we got on it, know how we're doing?
I was just grading based on completion.
Okay, thank you.
If you completed it, you get 30 points. And if you want me to go over it with you, I'll be glad to go over it with you in my office. I'm happy to do that. Yes.
So as of right now, our grading class is just like an average.
That's it. That's it. That's why those that are persisting along, if you do well on this test and the next test and the final, you can get a C or higher. It's all dependent on how hard you work.
How much is that for?
10% for all of them. I've had like 8 assignments already, or 6 assignments already so far, and this is just like worth 30 points. So I add up all the points at the end. It's 10% of the grade. That's it. It goes into Excel spreadsheet and calculated. It's nothing to do with yes.
A lot of us do that like final grade calculator at the end. So would there be a way like we could see our grade before the final exam and stuff, like do all the configurations that would be?
No, because basically I don't do that until I see the final exam grade, because the final exam is worth either 25 or 30% of the grade.
Okay, so we won't have any kind of grade before the final
No, I
exam.
don't want you to worry about that. I want you to do your best in the final and not worry about dwell on the stuff you weren't perfect on before. Okay?
What if
I-
we've signed up for the next level already? What happens there? Like if we've signed up for one or two next semester?
Well, please don't be pessimists. Be optimistic you can do well and everything else. I'm not, when I say, for example, some people misread my direct statement of when I say figure it out for yourself. Is that an off-putting thing that basically says go away? Or is that saying I have confidence in you, you can work it out? What am I saying?
I don't really understand how to before the final exam.
Well, that's why you come see me in my office and bring in your stuff and I'll go over it all with you. I'm very happy to do that. Unfortunately, I'm not a mind reader. I can't look at you and say, or do a Vulcan mind meld with you or something and see what you're really not quite getting.
No, it's, what time is your office hours?
It usually 12:15 to 1:15 every day, but you can make appointment outside my other times. Yeah, any other questions? Because today, all I'm gonna do is finish off this little finish off the chapter with reinforcing was that we talked about last time that is gonna be on the test, residence forms and formal charge. Just finish off the chapter, and then I'll start the new chapter tomorrow. Yes.
Okay, so our final grade, we're taking our test at like 4 days. Will we find out our final grade or will we have to wait for that?
Well, I don't know what the college's decision regarding distributing final grades, because every college I've been at has their own schedule, and I don't think here I'm allowed to tell people their final grades. It has to come through the university because of funding reasons and all sorts of other reasons. So, yeah, I have a deadline when to turn it in. It'll come later. But I will post the 2 exam grades on Brightspace like I did before, but I'm not going to average them all out because I want you to see the scores and realize it's going to go in my spreadsheet, and then I'll decide at the end how it looks. Of course. What do you think based on what we covered? Is there really much math other than putting the formulas in? No, it's not. It's the electron configurations and the Lewis dot structures and such. It's totally different for the stoichiometry and such. Even people do better on the energy and gas law stuff that's coming up at the end, because that's just using the formulas and understanding the basics of the gas laws and everything. So people do better on that. The most difficult part of general chemistry 1 is stoichiometry, which was the balancing equations and all that other stuff. Naming equations, start up, balancing equations, but it's vital going all the way forward, all the way through biology. Okay? And that's why I like to give people a break if they don't do well on if I have 3 tests, if they don't do well in the first test, I'll can drop it when I have that liberty. I don't have that here. I didn't make the rules. I'm just a visiting associate professor. So, any other questions before I finish? Those of you who are distant, any questions? Okay, one more. Go ahead.
Well, mine okay. I was going over the textbook last night and it talked about the Rydberg constant, which was given in like moving electron shells, and the number that it gave was different than the number that we found in the lab. Do you know?
Well, that's due to the constant is slightly different or something, but I can't crawl and decide the head of who did the lab or whatever else.
Yeah.
The lab was just designed for doing it based on the numbers you were given.
Yeah.
And in a way, I don't have any control about how they get it wrong. The textbooks everybody uses is like 95% dependable, and they're going to make mistakes. I had a physical chemistry textbook where the study got, where the answers for the problems in physical chemistry textbook, most of them were wrong. So again, it's a kind of thing where it's all dependent on whether the author's careful or whatever else. So
Okay, but for the test, we would have questions like that.
I'll give it to you, or it'll be on the back of that thing. Okay.
All right.
And you had a question.
Yeah, I was just gonna ask if you could like go over like the equations and like kind of how they work, like the Planck's postulate and the Balmer-Rydberg and just like stuff like that.
Well, I'll be glad to go over it with you in my office. I'll be glad to go over that with you in my office. So please come see me, and then I can help you exactly with what you didn't understand. Okay. Any other questions? Any questions a distant way before I finish off this chapter? Okay, so I'm not getting into new material today. This is kind of review what we did before yesterday or Monday, and then finish off, and then we'll have our exam today, this evening, and then I'll start new material tomorrow. You had another question? Did you have? Oh, okay. All right. Very good. Okay. Anybody virtual? We're all done for the local people. Anybody virtual have any questions? Hopefully you got some out of my discussion of them, so I addressed your concerns about it and how I'm rating everything. But please rest assured I'm being as fair as possible here, and I want everybody to do really well on things to the best of your ability. But as I said before, please don't compare yourself with other students. Okay. And as I told another student, when I was in high school, I really loved baseball, but I wasn't very good enough to be a regular player. So I mainly sat on the bench and was only allowed to play in one game near the end of the season. So I had a nice time doing it then, but I ended up being, this was in the early 70s. I used the computer, the Wang computer with a card we had, and did the baseball statistics for the team, like junior and senior year. And I ended up getting a varsity letter for doing that. So I made the best of the situation. So basically I like to play chess, but I love baseball. So what I'm trying to encourage all of you to do is have some perspective that you're not in competition the same way you are in sports in this. It's all about you doing your best for this subject and preparing, because you're going to go on as an individual. You may end up living in California later or whatever else. And so that's just part of the college experience. Okay. All right. Any other questions? Yes. The periodic trends. Yeah. My slide's a little messed up, but yeah, I'll be glad to look at, go over that. I'll start that slide. That's fine. Okay, I'm going to share the screen now, folks. Please let me know that you can see the screen.
We can.
Can you see
Now
the
we
screen
can.
here?
Yes.
Okay, this is the periodic table, and if you look at the electronegativity, and what happens is you go to the right on the periodic table. And I know this is a little messy, but it's better on in the slides that don't have writing on them, because I have those also in this folder. So basically what happens is you go to the right on the periodic table regarding electronegativity. It gets more electronegative, and that's a tendency for the electron pair to be drawn to itself. It's really, really important to understand the nature of how that's supposed to work, okay? Electron affinity, as another student asked me, that's more a general trend as to if something has good electron affinity, it wants to draw things, but it's not necessarily a number, it's more describing the concept. So the number is electronegativity that's been determined experimentally. So if we look at that, the electronegativity is one of those periodic trends, okay? Yes.
And you said we don't need to know like the specific numbers.
No, if I may give them to you and ask you to tell me which is or give you the structure and ask, is it polar? So you have a general feel for which is more electronegative than the other one. Which is more electronegative, the carbon or the fluorine? Okay, so if you have a carbon-fluorine bond, where's the direction of the vector going to be? Towards the fluorine, yeah, very good. Okay.
Dr. Douglas,
Yes.
if we don't have the numbers, how will we determine if it's polar or ionic?
Well, just by the trends. If it's not equal, it's going to be polar covalent. There is no such thing as polar ionic. It's polar covalent. If it's zero, the difference. If you have two chlorines, the difference is zero, right? So that's fully covalent. Okay. But every other bond that has a difference in electronegativity, even the carbon and sulfur bond, even that's a little bit polar, even though the numbers are 2.5 for each of them. Okay.
But Dr. Douglas,
yes.
I remember on our thing, it's between 0 and 2 is polar covalent, and if it's 0 is covalent, and then if it's greater than 2, it's ionic.
No, it's still polar covalent, but the thing is, it's more ionic than it isn't. It's not as a cut and dried as that. That chart again with those numbers above 2 difference saying it's ionic is just what the author said to kind of give you a barrier, but in reality, it's more complicated than that. It's still polar. It's still polar until it becomes ionic, and it's ionic only that matters is when it gets dissolved in water. Then it breaks into ions. But without that, it's going to be a solid, and it's essentially in crystalline form. So that's related to whether it's dissolved in water or whether it's solid. Okay.
But
yes, Brandon.
I don't understand how you're saying like ionic bonds, like there aren't ionic bonds, but we have like on like
no, like for example, you got cesium fluoride. Okay, let me draw on the thing with cesium fluoride. Just looking at this here, cesium fluoride. The cesium fluoride. Oops. Sorry. Let me go back here. Fix the pointer. Cesium fluoride. The cesium here will be a +1, right? And the fluoride will be a minus. That is because the fluorine is very electronegative and likes to draw the pair to itself. But notice where the pair is there. Where's the pair? It's just closer to the F. But does that mean that the cesium doesn't see the pair at all? No, because basically when it's in solid form, it's still in a crystalline form, and your book has an example of the crystalline form later. So the crystalline form does have connections, but they're more ionic bonds when they dissolve in water that still matter. So that's the only difference. Okay. So but I appreciate the question. Now, yes.
So when the elements are bonded that are close together, those would be covalent?
Yeah, usually, and there would be polar, like for example, if you've got like C, then an O, then an H, okay, with this, and then you've got the electron pair there, This is covalent, but there's a difference of one between the C and the carbon, between the C and the oxygen. So essentially, the things will be directed in this direction based on which is more electronegative, the vectors. So again, it's the same thing of that the electron pair is closer to the oxygen, but that doesn't mean, and for example, in certain conditions, this hydrogen could go away and become H plus. Certain conditions, it is an acid. Like in the case of phenol, it's an acid when you got the oxygen hydrogen bond. Okay.
Would that molecule be polar or
Well, it's polar because it has a hydrogen on one side and a carbon on the other, and the electron pairs there. So it's still polar because it's different, just because it's different. Yes.
Are you going to draw the vectors?
No. That's just because some of you might understand the math better, and it's just another tool. So. No. Just understand the trends. As you go to the right on the periodic table, it's more electronegative, and down it's less. Okay, because they're bigger.
How do you want to complete a problem like this if we don't have it?
Well, you work the problems in the book when you have the numbers. Then you understand the trends. And if you need the numbers, I'll give them to you. I'm not asking you to memorize the numbers. Like if I had a problem where with carbon, hydrogen, whatever else, I would give you 2.5 for carbon, 2.1 for hydrogen. And
You're going to give it to us if you want.
yeah, if I want you to do something with it, I'll give it to you.
Okay.
I'm not asking you to memorize the numbers. That's not the point. I want you to learn the concept here, okay? Biology, you're expected, this is why I didn't do well in botany and zoology. I don't care what people know. I got C's in botany and zoology. Why? Because I couldn't memorize all the plant and animal part names. It didn't fit what I learned, logical thing regarding naming of compounds and everything else. It's more directly related on function or the Latin term. So again, it's a very memorization is useful for some classes, but not necessarily for chemistry or physics. Okay.
Dr. Douglas, so I'm just confused. So you're not going to ask us about naming, like I just don't understand if you say, is this ionic, polar, or covalent or whatever, like.
Well, I did on
How
the
do we do that just by knowing the
I
trend?
did on that worksheet that say polar, whatever. You just look at it and answer the question based on the worksheet. And is it polar? It just doesn't look different from one side than the other. Essentially, you can look at it and say that it's polar or not.
But what do you mean by look at it and see if it's one side's
Well, let
different?
me go to the next slide. Let me go to the next slide here. It'll show you here. Let me go to the next slide on this, okay? Sorry. I don't know, it's not moving. Wait a sec, there's something wrong with I gotta fix the PowerPoint here. Yeah, it's not working properly. Okay, hold on a minute, please. Okay, I have to open the PowerPoint again. For some reason, it isn't cooperating regarding you even being able to see it. Just a moment. Okay, I'm going to share the screen with you again. My apologies. Okay, can everybody see this now? See if I can move forward with it. Okay. All right, these are the periodic trends. Again, variation of electronegativity with the thing. Again, electronegativity, it goes higher electronegativity as you go across the periodic table. And that is the kind of trends. The next one, classification of bonds. These are the examples that I gave you before. And hopefully, Brandon, this will answer your question. When you have two chlorines together, like over here, right? There's a 0 between them, correct? And then with cesium fluoride, you have a 3.3 difference. So the cesium will be here with a +1, and the fluorine will be over here with this electron pair tight to the fluorine, and this will be a -1. But the cesium still sees it, but it'll form a crystalline structure. Again, if you have HCl, you'll have 2.1 here. But again, I just want you to understand the trends based on that, based on the periodic table, just being able to look at it. And please don't worry about the numbers regarding that. Now, the difference in the bond type, again, this is the slide that you were asking about. These are just trends. Above 2 is considered ionic in general terms. And then between 0 and 2, it is considered polar covalent. But in reality, even above 2, ionic isn't necessarily, it can go from 2 all the way up to 3.3. So some are more ionic than others, yes.
So unless two of the same elements are bonded together, you would consider it a polar molecule?
Yeah, unless it's the same thing bonded together, it would be considered polar. Okay, even if it's like this. Is this polar just by looking at it? Yes, it's different. How about if you put a chlorine there? Is that polar? Yes, because this looks different than the other side. Okay, so again, it's just a matter of looking at it and answer the question, is it different on one side than the other?
So if there was just carbons around the carbon, then it would be nonpolar.
If you have that, is that polar? Yes, because oxygen's different from the sulfur. Okay?
Is it with the middle element too, or just the side elements?
Well, it's all related to the middle element. So yes.
Can you give an example of another nonpolar?
Nonpolar?
Yeah.
Why is that nonpolar covalent? It's symmetrical, yeah. So essentially these vectors will cancel out each other. So it's still considered nonpolar, but if you put the two chlorines here, these are different isomers, but you'll see them in organic. This is polar. And it reacts differently when it's a solvent, okay?
So Dr. Douglas, do you want us, you said that polar covalent goes up to 3.5 or 3.3. So on the test, do we put that, or do we put ionic like the power?
No, if it dissolves in water, it's considered ionic. So you could kind of look at it that way, that basically, I'm not going to be that much of a stickler regarding it. I just want you to see the general trends. I don't like this author putting it at 2. I've used other books where they have a total thing. The 0.0 difference is covalent. And then at the about 3.3 difference is considered ionic, but it's a trend that goes anywhere in between. Everything in between is called polar covalent because there's always degrees of sharing the electrons between them.
So what do we put on the test?
Well, again, I just want you to understand the general concept. I'm not going to trick you. Please don't think I want to trick you and these nuances that you're concerned about, because I don't want you to worry about that. Yes.
Will we have to like draw these on the test, or is it multiple choice?
There'll be 15 multiple choice questions, just like, and then 8. So I will ask you to do structures. I will ask you to do Lewis dot structures, just like in the worksheets. And basically the partial things, and the ionic is the transfer electrons, and ionic usually only form in water solution. So let me get rid of what's on the slide here. Okay, ionic is a transfer of electrons, and the transfer only occurs when you have a water solution. because essentially then those ions can break off and coordinate around the water molecules. Until then, you got a crystal structure where they're all together anyway and bonded. And it's just based on the electrostatic difference there. So that's why I like it to be there with the thing, not worrying about where the 2 is, okay? Okay, so let's continue here. Ionic and basically the things, cesium chloride, H2S. You have H2S, it looks like this. Is that going to be polar first? Yes, because it's going to be look different because you got these electron pairs on the top and the bottom. It's not linear, and because the sulfur and the hydrogen is a difference of 0.4, it's still considered more covalent than it is, but it's still polar covalent directed towards whatever is more electronegative, which is the sulfur. Okay, so there is a polarity aspect to it. Okay.
Can you show us a nonpolar example?
That's nonpolar. Okay, so is this. Okay, for different reasons. Okay, that's nonpolar. Even this is nonpolar. Why is that nonpolar? Because it has 3 resonance forms, because the double bond could be here, here, or here. So they basically, they're all things. So even that's considered nonpolar. Okay. So basically, I need to get to the new things here. This is the Lewis dot structures. I do want you to use the method in the book or use mine, whichever is useful for you. And then you complete the octet. If you want to use the rules for this, nitrogen fluoride, and again, feel free to use this and follow the slides when you're working the homeworks. Otherwise, just do it with my little method to do it. And it really doesn't matter which one, whichever you're more comfortable for. And I went through this myself with this and put C in the middle and then draw them. And basically that's the slide here, and then that's there. Possible 2 structures of formaldehyde with this. An atom's formal charge is the difference between the number of valence electrons that are in an isolated atom and the number of electrons in between there. And then basically the formal charge, you total up the number of valence electrons in the free atom and then subtract the total number of non-bonding ones and half the total number of bonding electrons. But basically I want you to see it as kind of, if you make the things here, does any of the things around it borrow electrons from it? And I'll go with some examples in the next part here. Okay, so essentially this is how they do it on the slide. Here you have these with this one, and you can figure out what the formal charge is on that. That is 0, based on calculating those in there. You get a 0 formal charge. But what if you add something like SO4 minus 2? Okay, and basically you put the sulfur in the middle because it has 6 around it. You put, where are you going to put the oxygens? You can use this method or you can use mine. Where are you going to put the oxygens? In 4 places around this. So there'll be 6 around this oxygen, then 6 over here, and then 6 over here. Okay, this is SO4 minus 2, and then another over here like this. 6 there. These 2 electrons are borrowed by the oxygen. They're already a pair, so the formal charge of this becomes +2 now, and each of these now are -1 because you add an extra electron from the 2 here, and essentially you have a +2 and a -1, a -4 all around. So -4 + 2 is equal to -2. So essentially you have a +2 there in in the center for the sulfate. Yes,
To show the charge of the molecule, you have to do brackets and then the charge, right?
sure,
Okay.
correct. Or the charge within it
Okay,
in the brackets, but that's with an ion,
okay.
with an ion.
Can you draw the final structure?
Yeah. Hold on a minute. I'm going to stop the share and add a slide. Hold on a sec. Just a minute. I'm going to add a slide here. Okay, here we have a slide and a slide in here. I'm just going to do a couple examples here. Sulfate, the final structure will look like this with 1, 2, 3, 4. This will be -1. This will now be also oxygen up here with this around it, -1. This will be O over here with a -1 next to it. This is +2 formal charge in the center. And then you got the oxygen there, over there, which is a -1. But how many electrons are around each of those atoms? Count them. No, how many electrons all around each of those atoms? This has 8, this one has 8, this one has 8, this one has 8. They all have 8 around them. So they're happy even though the sulfur has a formal charge of +2.
Dr.
Okay.
Oz, how does the sulfur have a +2 charge when there's 8 valence?
Because essentially that you put an oxygen up here that had 6 on it, right? Like this. And that you have an electron pair there, an electron pair there in the sulfur, and then 1 there and 1 there. Over here, you put an oxygen that has 6 there, right? On the other side, you have another oxygen that has 6 there. This forms a bond. This forms a bond also. Okay, you got a bond there and a bond there. Okay, you have another oxygen with 6 here. But these are all that belong to the oxygen, right? So it sees these electron pairs. They're available to share, right? They're on the sulfur. They're sticking out from the sulfur. So it'll grab these and it'll form a bond, just like that one will form a bond. That's considered the formal charge. That gives it a +1 for each. +1 there because it's borrowing one of the electrons from the sulfur. Okay, so essentially it gets +1 twice, and so you have a +2 formal charge for the center, but now because it's a -2 for the whole thing, this now adds 2 more in there, and you have -1, -1, -1, -1, and that's a perfect example showing how it works.
How, if it's a -2, then why do 4 oxygens get a -1?
Because the center is +2, right? We just said that formal charge is +2 in the center. -4 +2 is what? This is the sulfur, right? This is each oxygen is -1, right? So you have the +2 and the 4 thing. So the total charge of the whole thing is -2. And that's what the ion looks like. Okay? So basically formal charge here. For neutral molecules, a Lewis dot structure in which there are no formal charges is preferable to those that are formal charges are present. Okay? You want them to be neutral as possible. So say, for example, if you have carbon with 4 hydrogens around them, what is the formal charge on the carbon? 0, because it had 4 things in there. It didn't need to provide any electrons to form a bond. Okay? Okay, so there are a whole variety of things like this. If you put an oxygen in here and like that, what's the formal charge of the carbon going to be now? Still 0. Okay? Okay, so basically if you put it like this with that, What's the formal charge of that one going to be? Still 0 because it shared a bond with the carbon all in the same place. It's still 0. So that's preferred instead of getting something that is a more complicated formal charge. Okay? But in the case of sulfate, which we did before, it likes to have a formal charge for the sulfur +2 because then it could form a bond with each oxygen and be it all around like that. And essentially you have those two together like this. And then essentially I'm going to erase what's on the slide and put the things on there. We only have 3 minutes left, so I want to finish the slide. So I'm going to go quickly through the end of these. But let me delete them and then things, because I'd like you to read the rest of the section and just practice some problems at the end of the chapter for that. Lewis structures with large formal charges are less plausible with small ones. And among Lewis dot structures that have similar distributions, the most plausible one, you have negative formal charges are placed on the more electronegative atoms. And unfortunately, this example they give, that molecule doesn't exist practically. It's not a legitimate form because there's a -1 formal charge on this carbon and a +1 there. So it much prefers to have the double bond like that. So it is, the formal charge on this is 0. That is preferable to having formal charges on the carbons the other way. So that's why you don't line them up like that there. And that is 0 for both. Okay?
Does the first equation have a carbon forming?
Because it grabbed an extra electron from somewhere and the oxygen lost an extra electron. It doesn't like that because it doesn't have eight electrons around its thing. It's got 10, it's different in the sense of that. Okay, you want to have 8 around each of them, not a shortage or extra around the carbon. Okay, resonance structure. I already talked about resonance structures, the 2 examples there, and we already went through that with the carbonate. So that's the last part of that, the resonance structures. Exceptions to the octet rule basically are things like this. The only reason this is an exception is because beryllium only has 2 electrons anyway. So it's an exception to the octet rule. And then BF3, same thing, there's only 3 there. So it's an exception. Odd electron molecules essentially looks like that. That's just odd on it. So if you're asked to do that in a homework problem, you could do it. But I'm not going to do that on the exam. That might be on the worksheet, but you could put it there too. That's considered a free radical, and it's particularly reactive. Okay, and then here with SF6, it looks like that. And that is based on what we're going to do the next chapter. So that's kind of there. And then bond enthalpy, the breaking of bonds, we haven't talked about energy left. So this is not, the bond enthalpy in this chapter is not going to be on the test at all. That will come up when we talk about it in chapter 9 or 10, which is the energy one. And then average bond enthalpy there, and then essentially that finishes the chapter. So bond enthalpy is covered later. Any final questions? Okay, I'll see you tonight at 7 o'clock or 8 o'clock. Email me if you have any, and my office hours at 12:15, so come by if you want individual help. Okay, those are your distance. Any questions?